All right, Calc BC, we're going to do the last problem here in our notes. And with the limit as x goes to infinity of x to the 1 over x. And so if we evaluate that limit, we're just going to get infinity to the 0. And so as you know, with the other ones we've been doing, it's like, who knows? Infinity to the 0. It feels like it should be 1 because it's something to the 0. But if we of course know that infinity is not a number, and so maybe it's infinity because it's infinity to something. So we really don't know. We really aren't sure here. And so we know that from the ways we've done these other ones, we're just going to take the natural log. So we're going to do the limit as x goes to infinity of the natural log of our function is equal to the limit as x goes to infinity of the natural log of x times 1 over x. And of course, we should just go ahead and take that to the bottom. So we're just going to do, it's the limit as x goes to infinity of the natural log of x over x. And if we evaluate that, we get infinity over infinity, which is one of our indeterminate forms where we can go straight to L'Hopital. So let's L'Hopital. And we get the limit as x goes to infinity of 1 over x divided by 1. And if we evaluate that, we just get 0. So what we showed is that the limit as x goes to infinity of the natural log of our function is equal to 0. But we don't want to know what the limit of the natural log of our function is. And of course, our function, if I didn't say that earlier, is x to the 1 over x, right? We don't want to know what the limit of the natural log of that is. We want to know what the limit of the function is. So we're going to exponentiate it with a base of e. And so the limit as x goes to infinity of our function is e to the 0, which is 1. And so it was 1 in this case. So it was what we thought maybe it would be because it's to the 0. But that's not always the case. As we talked in class, because not all infinities are created equal and not all zeros are created equal. And you might say, what? Not all zeros are created equal. Well, the limit, for example, as x goes to infinity of 1 over x versus the limit as x goes to infinity of 1 over x squared, right? They're both 0, but which one gets to 0 first, right? Like which one gets there faster? Clearly, this one gets to 0 faster or sooner, right? And actually, interestingly enough, in 8.3, so in section 8.3, we will look at relative rates of growth. And we'll ask ourselves, which of these functions has a faster type of growth? So anyways, that's the last example. Have fun doing your homework. Thanks a lot.